Hello, good evening. Welcome. Let us look at this physics question. A pendulum bulb of mass 1.5 kilograms is attached to one end of a string of length 0.8 meters. The bulb moves in a horizontal circle in such a way that the spring is inclined at 30 degrees to the vertical. Calculate I, the tension in the spring. I, the period of the motion, and we are to take g, which is acceleration due to gravity, to be 10 meters per second squared. Right, so let us look at the solution. The whole thing is sketched here. First of all, we have a bulb that is tied to a string, and it is being whirled in a horizontal circle. This is what we call the conical pendulum. Now you see that once it moves in that horizontal circle, the spring becomes taut owing to the tension in the spring. And once it is moving in a circle, there is a force that is keeping it in that circular path, which we call the centripetal force. So the centripetal force is provided for by the tension T in the spring. But since the bulb is moving in a horizontal circle, we are going to see that the tension, we will resolve the tension. One, vertically we will have T cos theta, that is tension times cos the angle theta. Then the horizontal component will be T sine theta. And this T sine theta is equal to the centripetal force. Remember, the centripetal force acts towards the center of the circle. That means that the centripetal force F is given by mv squared r, and this is the same as mw squared r, where w is the angular velocity of the bulb that is moving in the horizontal circle. But first, they say we should find the tension in the spring. Now, when we look at the diagram, you will see that T cos theta, which is the vertical component here because of the horizontal movement of the circle, this T cos theta will be equal to W, which is the weight of the bulb, which is equal to mg. So I'll say that T cos 30 degrees, remember T, I have explained, is the tension in the spring. This is equal to 1.5, which is the mass of the bulb, times G, which is the acceleration due to gravity. So you see that my T would be equal to 1.5 times 10 will be 15 divided by cos 30 degrees. That gives us 15 divided by cos 30 degrees is 0.866. So let us divide this and see. Let us divide this 15 divided by 0.866. That gives us 17.32 newtons. So that is the tension in the spring. I say that we should find the period of the motion. Period of the motion. So let's look at how we find the period of the motion. Now we have stated that the centripetal force, which is the force that keeps the bulb in the horizontal circle, is given by that is II, is given by mw squared r, where w is the angular velocity of the bulb that is moving in the horizontal circle. And this is equal to the centripetal force. The centripetal force in this case is T sine theta because it is acting towards the center of the circle. That gives us T sine theta. Now, if you consider the diagram again, you realize that we have a right angle triangle. Let us say that this is A, B, B, and C. You will see that when I consider this angle, I can say that sine theta is equal to opposite over the hypotenuse. Yes, we have sine theta is equal to the opposite, and the opposite here represents the radius of the circle. You will see that. So that is R. Then the hypotenuse is the length. Remember, not the tension, it is the length of the string. And that is indicated as L, big L. So let us make R the suffix. When we make R the suffix, R will be equal to L sine theta. So let us now substitute R is equal to L sine theta into this equation, which will yield mw squared L sine theta is equal to T sine theta. Now look at sine theta on the left hand side, sine theta on the right hand side. So they cancel out. Then you shall write mw squared L is equal to T. I am looking for period. So let us find the angular velocity first. So W will be equal to T over NL. That's W squared. W squared. So then W will be the square root of T, that is the tension divided by the mass of the ball times the length. So let us find this, that is equal to, you see that we found the tension to be 17.32 divided by the mass of the ball. The mass of the ball, which is 1.5 times the length, that is 0.8 meters. So let us see, my W will be square root of, let's see. Let us see. I will say that 1.5 times 0.8. That is 1.2. So I am going to say that this is equal to square root of, let me clean this, into 17.32 divided by 1.2. Okay. 17.32 divided by 1.2. That gives me, so my W, you can say that my W will be equal to the square root of 14.43. That is 14.43. All right, so the square root of all this will be 3.79. Now remember, the question says that we should find the period of the motion. Now with angular velocity, period is, let's say, Tp. Yes, I am distinguishing this period because the symbol for period is T. But I don't want it to conflict with the tension T, so I am using this small p to mean the period. And it is given by 2 pi divided by the angular velocity. So this will be 2 pi divided by 3.79. And when you do this, that will be 1.65, approximately 1.65 seconds. And that will be the period of the motion. Thank you very much. See you again. Bye-bye.